Okay, so again, we're doing trend lines and correlation 6-6. So we're going to determine a trend line equation from a scatter plot, and we're going to describe the linear correlation of a given data set. Okay, so some new vocabulary we've got today. All right, so first up, scatter plots are used to illustrate the relationship between two groups of data. So like if we look at this table, we have the year and the sales revenue. That's what we're connecting, two groups of data. Okay, while these points rarely lie on a straight line, okay, very rarely does that happen where you see like a direct, exact, perfect linear growth in your company sales or revenue or any of those things. Okay, so it rarely lies on a straight line. So we can talk about trend lines. A trend line can often be drawn in a scatter plot to show the relationship more clearly so we can see what's happening. Trend lines are drawn as close to as many of the points as possible, because you can't get all of them, then it wouldn't be a line, right? If you're connecting the dots. This is not connecting the dots. Okay. Graphing calculators and spreadsheets can find the exact equation, and it is called the line of best fit when they do that. We're not going to use a graphing calculator or spreadsheet today. We're just going to do a trend line. So that's where we're going to use a ruler and connect the points. Yep. Yes. Looks like a brick. Elaine has one. You are correct. Okay. So in example 1, we want to draw and determine the equation of a trend line that models the sales revenue. So again, we're talking trend lines, which are an estimation. Calculators and spreadsheets will give you the line of best fit, which is an exact. Okay, but we're not going to do the math for those. All right, so example 1. Carefully estimate and draw a trend line that minimize the distances to the data points. So you want to take your ruler and put it on there where you're getting, it's a little easier. Can I borrow one of the clear ones actually for a minute? Okay. So to put it on there where it's in the middle of all of those points. When you're looking, it's kind of hard to decide. Trying to get all your points in the middle. So see, like I have 1, 2 points over here. These 2 points are kind of on the line. That one's kind of on the line. This one's on this side. Let me go. Maybe if I go a little bit more this way. Then I've got like 3 on that line, 3 touching. They're all pretty close. No, it's not. Oh, is there a dot? Oh, there's a dot on the blue. I see. I was like, wait a minute. There we go. That makes sense. That would help. I was like, wait a minute. Why am I not getting the right? So if I'm looking and I draw my graph here, that's a pretty good trend line, right? I have 1, 2 there. I have 1 on this side. 1's right on the line. Kind of getting them to touch. Maybe if I move it a little bit closer. So we can kind of go through there and draw our trend line. Okay. Okay. So and so your equations today might be slightly different, like on your homework, if your trend line is a little different than somebody else's. There's going to be some wiggle room, okay? Because the next step says to choose 2 points on the trend line. So like this one's a pretty close intersection here at 1972 and 6. So we'll use that one. And this one looks pretty close to my intersection as well. So I'll use that one, which is 2002 and 16. Okay, so I'm picking points off of I picked 2 points off of my trend line. I tried to find where they were pretty close to intersecting my line. Right, like those are called minor grid lines, but where your X and your Y meet, so you're not trying to estimate as much. Okay, so again, my 2 points on my trend line are 1972, comma 6, because 1972 is my year, and 6 is my millions of dollars. And then my other one is 2002 and 16. So what do those numbers represent? The dollars and then the year. So what? This is my X and Y. So what are the dollars in the year?
How many $1 million per year?
$1 million per year of what?
Of
sales revenues. Okay, so this is my sales revenue as well. So in 1972, I had how much money in sales revenue? $6 million. Okay. 2002, I had how much in sales revenue? $16 million. All right. So I picked 2 points. Next up, find the equation of the line passing through those 2 points. How am I going to write an equation of this line? Okay. Go ahead. Okay, slope-intercept form. Do I have my slope? Do I have my intercept? Okay, so I can't just use that. I do want to get it in slope-intercept form, like I want to write the equation, but I have to think about, well, what information do I have? This goes back to the notes where we had the different ways to write an equation from all the pieces of information. Yep.
We have 2 points, so we're going to need to use, I forget what it's called, what is it?
2 points on a line.
2 points on a line are given. Yeah, we've got 2 points on a line.
Yes, we need to use y2 minus y1 over x2 minus x1.
Okay, good. So we need to find the slope, which is the y2 minus y1 over x2 minus x1. Good. So we can use those 2 points to find the slope. That's the first thing we need to do. Okay. So what would that numerator look like? What would the numerator look like? What numbers would I plug into the numerator? The 6 and 16. So which one do you want to put first? The 16? Okay, so 16 minus 6. And what will my denominator look like? 2002 minus 1972. Okay. 16 minus 6, pardon me. 10. 2002 minus 1972. 30. All right, so 10/30ths can still simplify to be 1/3. All right, so we just found out that your slope is 1/3. Helpful. Incomplete, but helpful. Okay, so now what do we do? Junior, what comes next when we have 2 points on the line are given? We found the slope. What comes next? Okay, so use the slope, which we've got, and the coordinates of either point. Which point do you guys want to use? The 1972? Yeah. Okay, so just because it's first. All right, so we're going to use this one, and we're going to find our equation. So how are we going to find our equation? You've got 2 different options of how you could do it. It depends on which way you go. What was it? Okay, well we picked one of the coordinates. We picked 1972 and 6. So now we have a point and we have a slope. So now there's 2 different ways you could solve it. Yep, if we want to use y equals mx plus b, then the y would be 6. So we'd have 6 equals, our slope is 1/3. Our x is 1972 plus our b. Okay, so we can solve for B. Great. So 6 equals, what's 1/3 of 1972? 1972 divided by 3.
Sorry, I'm using different points.
That's okay. You chose the 2002 and the 16? Or you have different points?
I have different in general.
Okay.
I have 1996 and 14 and 2007 and 18.
Okay.
So,
What was it? Okay. Can somebody confirm that? 673, you said? I do not have 672. 657? No? Hold on. Well, maybe. Because this one, the book did it differently. I was just looking at the book's answers. It did it differently. But I'm still waiting for someone to confirm your answer.
657.3 repeating.
Okay. So it is 657.3 repeating plus B. So then what? There is no Y. We subtract 657.3 repeating from both sides. My thing moved. Okay, so what's 6 minus 657.3? Negative 651.3 repeating equals B. It just says 0.3333334. You can't put it in as repeating. Yeah. All right, so then do we have our equation? So how do we get our equation? Now we have to put it in slope-intercept form. Okay, so what would that be? That's not y slope-intercept form. That is the other way you could have solved it. That's point-slope form. You could have done y minus y1 equals m times x minus, or plus, pardon me. No, minus. Minus x1. You could have done it this way as well to solve and get your equation. Then you would have had y minus 6 equals 1/3 times x minus 1972. Then you would have had y minus 6 equals 1/3 x minus 350, or 657.3 repeating. And then you would have added 6. And so you would have had y equals 1/3 x minus 651.3 repeating. That is the slope-intercept form. But that's the thing. Like here, you could do either one. You could plug the slope into the y-intercept, or like the slope-intercept equation, and solve for your y-intercept. But then you have to take that next step and write your equation. Y equals 1/3 x minus the 651.3 repeating. It does not matter. You have options. You've been taught 2 ways to do that. The first thing you have to do is find your slope, and then how you get it into slope-intercept form is up to you. Okay? It depends on the day. Depends on the day. Nope, you totally can, because this is a point-slope form. If you have a point and you have a slope, you can do it. But if you can't remember this, then if you have a point and a slope, you can do this one too. It kind of depends on what you remember and what's fresh in your mind. All right, so great work there. Then we need to move on down to the next part of trend lines. Trend lines can be used to make predictions and estimates related to the data. Interpolation, okay, is just the process of making predictions that are within the range of the existing data points. So it's like, oh, well, how much do you think that how many millions of dollars of revenue do they have in 1968, right? That's within this data range from 1960 to 2010. Extrapolation is the process of making predictions outside the range of existing data. So if I ask you about 2015 or 2020, okay, it's outside the range of the data. So I think it's pretty natural to think that interpolation tends to result in more accurate predictions, right? Because it's the information inside the data that you're drawing from. You don't know what's happening from there. So with that being said, example 2 says use the results of example 1 to estimate the sales revenues for 1995 and predict the year in which the company will have sales of $24 million. Which prediction is more likely to be accurate? So what do you think? Okay, you think the first one's going to be more accurate? Okay. So 1995 would be more accurate because it's within the range of data, or it's interpolation. That's true. Should be. So now we need to actually do our estimates. It says use the results of example 1 though. What was your result of example 1? Well, yours is different. True. Okay. In your homework, it would be ideal to have a fraction here instead of this repeating decimal, but okay. No, it's fine. So how would you use these results from example 1 to estimate the sales revenues here? Like for 1995. Yeah, because you wrote an equation for the trend line. Correct. Okay, it's going to be a prediction. So how do we use that? How do we make a prediction with this equation we just found for the year 1995? Okay, if you look back at the graph, the year is 1995. Was that an X or a Y? You don't add up anything. The year is the Y. Okay. I asked a direct question that will lead you to a direct, correct answer. The year 1995. Is that an X or a Y? It's an X. So we need to put 1995 into our equation for X. Yes, that's it. We're like picking the point and we substitute it into our equation. So Y is going to equal 1/3 times 1995 minus 651.3 repeating. And you can find out what Y is, which is their millions of dollars of revenue. So 1/3 times 1995 minus 651.3. Have you already done your math, August? Okay, I was like, because then I'll see. I would compare it to what we got. You should have about the same. Well, that's why it would be handy to have a fraction, yes, instead. So you could subtract 651.33333 until you run out of space and then hit equals. Okay, so what'd you get? Negative 52.8 is not correct. I was like, how do we only have, like, either do, if you don't have a calculator, you can do some math on the piece of paper. Like, what time is it? Okay, good. 13.66. Okay, so there is our y. For what year? 1995. Okay, so, and we're supposed to estimate. Okay, so we could say in 1995, it was about $14 million revenue. Did you get about 14 million?
I had a brain fart and I can't remember our questions.
Okay. Oh, because you plugged in 19. Oh, just do the math here because they're on the same side. But that would give you a negative number.
Okay.
Yeah, you should just be able to do 3,990 minus this. But that's going to give you a tiny number. Yeah, a negative number. Not just tiny, but a negative. Oh, but you didn't use 1995. Wait, but you did here. You just abbreviated. Okay. Okay, I see. Let's see. Okay, let me go back and we can look at your math. All right, so go ahead and solve. Make your prediction for 20. What year was it? Oh, for the year. Okay, so when would you? How would you make your prediction for when the sales are $24 million? How would you make the prediction for when your sales are $24 million? No. You have an equation. Everything relates back to this equation. Yes. Okay, because the millions of dollars is on the y-axis. So we're going to plug 24 million in for our y. No, you're solving for x this time. Like you're starting over, you're plugging y in for 24, and you're solving for x, which would be your year. Okay. Okay, so you should have 24 equals 1/3 x minus 651.3 repeating. Okay. You add 651 okay, 3 repeating. Was 1/3 x, okay. You can't divide, like, you divided by 1/3. You did not divide by 1/3 correctly if you did that. No, it doesn't. We added 651, so 4 plus 1 is 5. 2 plus 5 is 7, so 600. You could multiply by 3, yes. Right, you can multiply by 3. Because 1/3 times 3 would cancel. You can divide by 1/3, but if you don't know how to put it in the correct calculator correctly, you're not going to get the correct answer. 675.3 repeating times 3 would equal what? Mm-hmm. 2000 what? 2025.9, isn't it? So it's an estimate. So about what year would that be? 2025.9 would be 2026. So in the year 2026, they would sell about $24 million of revenue is the estimate. Okay, so then on the back of your worksheet, we're talking about linear correlation. So linear correlation describes how closely the data points are clustered along the trend line is what we're looking for. So like, excuse me, if we drew a trend line in there, okay, they're clustered really closely. Okay, so this is considered a strong positive correlation. A strong correlation is the majority of the points are close to the trend line. That's a terrible circle there. Okay, so strong correlation is they're really close to the trend line. So these are really close, and it's positive because we have a positive slope, right? Our slope is positive. So that's why it's a strong positive correlation. This one is weak or no correlation. We can't even draw a trend line. Like, would it go this way or would it go this way? Okay, now weak correlation is that the points are not close to the trend line. Here, it just looks like a big blob. We can't really tell where to draw the trend line. This one, we could draw a trend line through there. The points are really close, so it's strong, and it's negative because our slope is negative. We have a negative slope. So it's a strong negative correlation. Looking back at the weak, like here, we can see that there is a trend line this way, but our points aren't close to it, so it's a weak trend line. It's a weak positive because our slope is again positive. This one, it's definitely going down. The points are not close to the trend line, so it's weak negative because again our slope is negative. The other thing to know is that trend lines with stronger correlations are more likely to produce accurate predictions. So if they have strong correlations, their predictions are going to be more accurate. Okay, and they're going to have because it's telling the stronger correlation is telling the stronger connection between your data values, like your revenue and the year. Okay, so there's a stronger correlation. So the predictions would be more accurate. All right, that's it. Your homework is 1 through 20 even. I apologize I didn't get all the answers on there. But I do have them written out here if you wanted to pause it and copy those down so you would know the answers so you could check. 16 is a graph, a chart. I didn't have time to copy the chart down, so that'll give you at least a good idea of your answers. All right, have a great day.